Algebra 2, Section 1.5, use problem-solving strategies and models. In this section, we're going to use models, equations, to find patterns that are reliable and predictable. So we're all familiar with y equals mx plus b for lines. The b is the constant fixed value. This is the rate, and this actually is the total. And we'll be using a similar linear equation for the models today. Example 1, high-speed train. The Acela train travels between Boston and Washington, a distance of 457 miles. Trip takes 6.5 hours. What's the average speed? Well, if you go back to section 1.4, we have a bunch of formulas for distance and some geometric equations as well. But if you remember, distance equals rate times time. I call it the DIRT equation. D's distance, R is the rate, T is the time. Well, we have here a distance. 6.5 is the time. We can find the rate, or the average speed. So filling these in, we have 457 for the distance equals R times 6.5. Divide by the 6.5 from both sides. And R will be equal to, and I don't have a calculator for this, so you guys can figure this out. That's the rate of the speed of the train. Next equation or next problem: aviation. A jet flies an average speed. Next problem: aviation. A jet flies at an average speed of 540 miles per hour. How long will it take to fly from New York to Tokyo? A distance of 60 miles. So again, DIRT equation. This time they're giving you the distance, the total, 6760, and they're giving you the number of miles. So that's going to be, I'm sorry, they gave you the rate. I apologize. That's the rate, R. So 540 times T. Find how long it takes to get there. Find the time. So we divide by 540 on both sides. Again, no calculator with me today. Just divide 6760, divide by 540, and you'll have some unit of time in hours. Now, next part, example 2, looking for a pattern. Again, we're going to establish an equation, a linear equation based upon some pattern, some repeatable pattern where the rate is constant with some initial value. So looking at this equation, it says paramotoring. A paramotor is a parachute propelled by a fan-like motor. The table shows the height h of a paramotorist t minutes after beginning a descent. Find the height of the paramotorist after 7 minutes. So at time 0, he's at 2,000 feet. At 1 minute, he's 1750, and he's dropping. So it's a decreasing value. His initial number here is 2,000, and he's dropping by, if you look how much he's dropping by each step here, it looks like 250 feet. So, again, just using a linear equation, we know that, let's see, so again, using this model of y equals mx plus b, the initial value is 2,000. And the rate is a decreasing 250. So the total y is going to equal negative 250x. So after each minute, he's dropping 250 feet. In 1 minute, 250, 2 minutes, 500, 3, 750, and so forth. Plus the 2,000 that you started at. Okay, so kind of do a mental check. At 1 minute, it is 1750. At 2 minutes here, it's minus 500. Okay. Well, now they want to know the total of 7 minutes. We'll just stick 7 into for the x, multiply by negative 250, subtract from the 2,000, and you'll have his distance. If you go too far into this guy will be underground, so don't go beyond the 2,000 feet. You'll see that as you do the equation. All right, next one's a good problem. Bottom page, example 3. Draw a diagram, and we'll do that. You are hanging 4 championship banners on a wall in your school's gym. The banners are 8 feet wide. The wall is 62 feet long. There should be an equal amount of space between the ends of the wall and the banners, and between each pair of banners. How far apart should the banners be placed? So a quick sketch here, what we're looking at here. We have 4 banners and a wall. So here's the wall, here's the corners of the wall, the 4 banners. So hanging down the wall, here's 1 banner, here's 2 banners, 3 banners, 4 banners. Now I'll try to draw them equal. And they're saying the space from the wall to the banners is the same as the space between the banners. And that's the unknown. So we'll call that X. So this is all X. X, X again, 1 more X, and yeah, another X. And we know the total distance from here to here is 62 feet. The banners are 8 feet each. Well, let's find out how much distance is between each of the banners and the wall. This total is 62. So 62 is the total. It's going to equal 1, 2, 3, 4, 5 X's. Plus, how much are for each banner? Well, there's 4 banners at 8. That's going to be 32. And now we can just go ahead and solve for X, which would be the space between each banner. Subtracting 32 from both sides, I think you guys will see this pretty quick. 30 equals 5X divided by the 5. X is 6. So it'd be 6 feet, 6 feet, 6, 6, 6. Again, check it out. Add these all up with the 8s and see they get 62. All right, next page. More modeling. This is a little trickier. Again, cars use 16 gallons of gas and travel a total distance of 460 miles. The car's fuel efficiency is 30 miles per gallon on a highway and 25 in the city. How many gallons of gasoline were used on the highway? Okay, so they did 16 gallons and that many miles. So this is the total, and this is the fixed amount of gas. So the total is, let's see, 460. So we have 460 miles. Now we have 2 rates. We have 30 miles per gallon, so we'll say 30 G. So 30 miles a gallon, how many gallons would you get as part of the 460? Plus the 25. Now, it says that 16 were used. So if we use G gallons here, and there's 16 total were used, where's that at again? Here's 16. We use G amount here, and 16 are total. For the 25, we would have to say that it's going to be the 16 minus G amount. So the amount was used here, and whatever was left is going to be used for the 25. The total will be 16. And then you're just going to now solve for G. So 460 equals 30G plus, and 25 times 16, 400. 400 minus 25G. Subtract the 400 from both sides and combine the G terms. So again, subtracting 400 and combining or simplifying on the right hand side, I'm going to have 60 equals 5G. Divide by 5, G equals 12. So 12 gallons were used here, and 16 minus the 12 used there got us the 460. So they want to know how many were used on the highway. And so we got G to be 12. Our answer would be B.